Hey everyone, thanks for coming to my talk today. My name is Andrew Yule, and I'm going to talk a little bit today about an R&D project that I've been involved with, in charge of at work. And it's dealt a lot with building an application in a CDF, and I'm going to talk about some of the lessons that I've learned working on that project. Just a brief outline. I'm going to talk a little bit about my company and what we do, and I think that's sort of helpful to frame the discussion and what's going to follow that. I'm going to talk a little bit about technology in the oil and gas industry, and then I'm going to formally introduce our R&D project called Alex, and then I'm going to talk through some of the things that I've learned with application development in the Wolfram language. And then finally, I'll just have a couple quick remarks about Wolfram language versus traditional languages and things like that. So about me, my background is in chemical engineering, and I only say that to sort of preface the rest of this presentation. I'm sure there's a lot of people out in the audience right now that are, probably a lot better than me at some of this stuff, but really my goal here is just to say, some of the things that I've learned over the last year and a half working on this, and I think some of them are really good, and they'll be really useful for a lot of people out there. I've got 5 years of experience in working in oil and gas now, and around my first year, halfway through my first year, I got introduced to Mathematica by a colleague, and I really challenged myself. I could see right away the value and what you could do with it, and I challenged myself to basically learn as much as I possibly could about it. And the way I did that is I forced myself not to open up Excel and open up all those other things, and I made myself do everything with Mathematica. And it was a little bit of a learning curve at first, but it's really paid off a lot now. I use it for everything. So just a quick company overview. My company, Assured Flow Solutions, we focus on specialty engineering and consulting in the upstream oil and gas section. The specialty that we fall under is what's called flow assurance. And basically what flow assurance is we attempt to assure that you have flow of hydrocarbons from your reservoir to your topsides. Most of our work is offshore, so we're dealing a lot with subsea pipelines. Primarily, and there's a lot of issues that you can run into that people wouldn't really think about. A lot of those are just pure sort of hydraulics. How do you produce from a well that's 20,000 feet below the ocean in 8,000 feet of water? Do you have the reservoir pressure that you need to produce that kind of well? There's a lot of issues we deal with that have to do with two-phase and three-phase flow. So sometimes when you're producing from a reservoir, you've got water, you've got oil, you've got gas, and it's all flowing in the same pipeline, and that creates a lot of operational issues that people aren't really aware of. Some of the other things that we focus on are some production chemistry type issues related directly to the oil. So this is a picture of what's called a hydrate. And hydrate, it looks very similar to ice, and it sort of is in some ways, but it's basically, it can form when you've got methane and water present in your pipeline. The real special thing about it is that it forms under high pressures and low temperatures, which is the exact environment that you have in an offshore pipeline. Just for reference, some of the ocean bed floor in the Gulf of Mexico is around 36 to 40 degrees Fahrenheit. So it's really, really cold down there. It's above freezing, but it's really cold. And the hydrates, they can form, the special thing about them is that they form above freezing temperatures. They're very pressure dependent. So if one of these forms and it blocks your pipeline, then you've got a major problem. Not only a safety concern, but you've also got loss of production, which is millions of dollars per day. So this is an example of an oil that's got a lot of paraffin content in it, and that paraffin, when it's exposed to a cold pipeline, it can deposit on the inner wall of the pipe. And over time, as it builds up, it can cause a lot of issues. You can see it almost to the point where it's blocking the pipeline right there. And then this is asphaltenes, which are another characteristic of oils, and sometimes they can precipitate out under the right conditions. And when they do, they just form. There's no way to dissolve them or anything like that. They form, and they can accumulate and block your pipeline. So we've got 4 locations, 2 in Houston, 1 in Dallas, and 1 in Denver, and we're sort of really spread out. We only have 20 people in the company, so for 4 locations, it's stretched pretty thin. We just opened up a new production chemistry lab. It opened last January, and the focus there was, we've primarily done engineering and consulting work before. With the production chemistry lab, we're able to do some of the fluid testing that we need to do on these oil samples ourselves, and basically be a third-party verification for some of that stuff. And it couples tightly with the engineering work. When you've got models that you're running simulations, they require parameters that you get from running these kinds of analysis on the fluid samples themselves. So it couples very tightly with it, and it was sort of something we're aiming to increase as far as coupling even more in the future. So in technology in oil and gas, it really comes down to one thing, and that's better drilling. When you're talking about spending tens of millions, if not $100 million to drill a well, especially offshore, anything that you can do to increase that process, make it more efficient, is gonna equate to a lot of money. So the downside of that is that we're generally late to the game as far as conventional technology, things related to computers and those types of things. And so the real thing I want to point out is that Excel is still very dominant. Everyone uses Excel. If you get something from clients, it's Excel, and if you send something, it's Excel. So technology at my company, so we use a lot of very expensive simulation software to sort of run our models, and that's sort of the base of it. But we're no different from anyone else in the industry. A lot of our stuff used to be Excel. It used to be one-off executables, and it used to be, it was just sort of scattered everywhere. Like I said, I personally use the Wolfram language for 80% of my work, and I've been trying to get that number to grow, spread awareness among my colleagues and things like that. But really about a year and a half ago, we realized that we needed something better. We needed some way that we could manage all these internal processes that we have and workflows and calculations. And so we decided to make something that would handle that. So like I said, we needed something that would handle these spreadsheets, one-off executables, and even just VBA macros. And then we've got even just company knowledge. There's people that have a lot of experience, and there's things that are in their head, and unless you go and talk to them, there's no way to get it out. And so we wanted to try to capture that as well in this. So before we started, we had this naming challenge for this R&D tool that we wanted to build, and the winner was someone who submitted the name Alex, and it was named after the Library of Alexandria, which was the largest and most significant library of the ancient world. And it was only about 2 weeks after that someone pointed out that library actually burned down. So we're hoping not to have the same fate with our Alex. So just really quick, let me kind of formally show you Alex. It's developed in Mathematica by me, and it's distributed to my colleagues via an enterprise CDF. Currently, we have 37 unique utilities in it, and those are sort of a combination of calculations, workflows, processes, all types of things. Basically, we just wanted a one-stop shop for anything R&D related that we had. I can open it really quickly. Like I said, it runs in a CDF, and over on this side, we've kind of got your main utility panel, and each one of these are unique. Over here on the left is where you've got a list of all the available utilities, and you can do some nice searching features if you need to search for a particular thing, and it'll sort of filter the list. So that's sort of what it looks like. Here's a better way to sort of look at some of the unique utilities that are available in it, and these are just some of them, not all of them, but just to give you a quick highlight. So like I said, it leverages the power of the enterprise CDF, and that allows us to have arbitrary input fields, and we can import file types of any type, which is really nice. The searchable field is also really nice. There's lots of times where you're not quite sure what utility you need for the job, and if you put in a few keywords, I've tried to make it so that it's easy to find that. I've also added support for 250 oil and gas units that we have. I know there's unit conversion built into the Wolfram language, but I wanted something that didn't require an internet connection, and something that we could easily build into the functional programming. So that's kind of what these will look like. Just one really basic example, and the thing that's nice about how it's built is that I can run this in Mathematica, and I don't have to run it in a CDF the way that my colleagues do. So this is a really simple utility, but we use it quite often to generate a hydrate curve, which are those things I mentioned earlier. And this basically shows us, as far as what is your temperature in your pipeline and what's your pressure. And if you're to the left of this curve, you're at a pretty big risk for forming hydrate in your line and blocking it. And if you're to the right, you're sort of okay. And we can add, inhibitor, which they'll inject a lot of chemicals into the pipeline to help avoid some of these operational issues. And you can see the effect of adding methanol basically shifts that curve to the left. And so you now have you can go a lot lower in your temperature and still not have still not have that operational risk. This is a little bit more advanced example. Some of the pipelines that we look at are really highly engineered pipelines. It's not a simple steel pipe that they're just laying on the ground. There's a lot of engineering that goes into the insulation of them. When you're dealing with temperatures that are a few degrees above freezing, you need to have as much insulation as you can. And so there's a lot of different wall layers in some of these pipes. And so we built this utility, and it uses ND-solve, and we can specify the wall materials, the thermal properties of it. And then if we calculate it, we can basically simulate, as soon as I shut in a pipeline, how long do I have in a cool down time until I hit some designated temperature. And that's going to be the temperature at which I'm at risk for some operational issues, normally hydrates. But the nice thing is, because it's an interpolating function, I can also look at these results, not just in the time domain, but I can also look at, I can look at them in the spatial domain and sort of the radial distance in the pipeline. So how did we decide to develop ALEX? We had a couple options. We had Excel, we had Visual Studio, and we had Mathematica. And I'm obviously a huge supporter of Mathematica. But at the end of the day, what it really came down to was that we needed something that we could develop very fast. Like we're not in the R&D business. We're in the clients and project business and stuff. And so we just needed something that worked, it was accurate, and we could build it really quickly. And so develop 37 different utilities inside of Visual Basic is not something that's going to take the amount of time that we needed it to, or the amount of time that we had. So the code structure, so the rest of these slides, I just want to go through really kind of briefly on each one how I've approached a certain issue related to application development with the Wolfram language, and just to give you guys an idea of how it's all set up. So ALEX is contained in a package. That's really nice for naming conventions. It makes it really easy to isolate your code, and using the different, the colon key or whatever, you can isolate it and grab a particular variable from a certain context. I also like the package editor, basically just because it allows me to collapse these different sections, and I can organize it really nicely. I can have an individual module and then everything related to that, and isolate out the methods from the UI and things like that. The other thing that's nice is when you have it in a package as opposed to a CDF, you can protect that and you can encode it, and that way your intellectual property is safe. So the insights into the UI, really quick. The whole thing is obviously in a CDF. On the top, we've got a docked cell, and then the remainder of the notebook is all wrapped around a dynamic module, wrapped inside of a dynamic module. And then each individual utility has its own dynamic module. And then inside of that is a pane, because a lot of these extend beyond the screen, and we wanted something that we could scroll through. And then over here, that searchable field that I mentioned before. And then just a pane here with a column of buttons in each one. If you click it, it sets the appropriate utility that you want to view. So all of us have written Mathematica code. We know that there's no compiling, and that's what's great about it. I did want to have something that would allow me to build ALEX, and what it basically does is I wrote this function that compiles to compile ALEX, and it takes the file as a package, and it moves it over to the appropriate user base directory for Mathematica and for the CDF player. And then in the process, it encodes it so that it's protected and you can't view it in raw text form. And what it also will do is update a version number that I can maintain separate from the utility. And then if I want, it has an option that it'll accept its own version number. So if I want to increment the next version number, I can do that manually. So version control, it's critical for any successful software project. And ALEX, because it's in a package form and it's a text form, it's very easy to maintain it using Git. And because it's raw text, you can do diffs on the different versions really easily. So it's nice as opposed to using a notebook, which has a lot of cells and a lot of additional text if you actually look inside of it, and that makes it a little bit more difficult for the version control. Updates. When I first started working on ALEX, there was updates sometimes twice a week, and I always wanted to make sure that people had an easy way to get the latest version. So I have all the files sort of associated with ALEX in one central spot, and then I wrote this little executable here, and that'll copy those files to the appropriate spot on their computer system under that same user base directory. And that way, when the Alex launches, it knows exactly where to go to look for those files, and it can load them in really easily. So this is something I've only recently started doing, actually, and I knew that Wolfram had automated testing, but I hadn't had a chance to really look at it yet. And once I did, I was really impressed. I mean, just like anything else with Wolfram, it's really easy to test your functions, and you can write, a few lines to change some variables and account for different things that the user might do, and then you can run a test, set that up as a test, and then when you run it, you'll easily see if you've broken anything with the past versions, stuff like that, which I tend to do. So it's nice to have this. Bug reporting. So right away, when I first built this, I built in the upper right corner this little button, report bug, and it uses the send mail function to basically send me a email, and with that email, I'll get information about all the variables in that utility, what current utility they're using, and it'll also send me, you can take a front-end screenshot using Mathematica code, and it'll send me a screenshot of that. And lots of times I can see, what are the red boxes or something if something's not working right. But you really need some way to do that, because Wolfram's really good about not letting their program crash. So you don't necessarily know that it just broke. You just know that something's not really working right. And so I needed some way to report that and let people know. And now I probably get one of these every 2 to 3 weeks. So there's been improvement. Debugging. I know there are ways of debugging inside of the package, inside of the notebook interface and other areas, but I tend to just do it directly in Mathematica. I like to be able to do exactly whatever my colleague that broke something, whatever they were doing, I like to repeat those steps in here, and then I'll generally just look at the exact variables, and I can look at just the raw data and things like that, and I can kind of figure out what's going on like that. That's how I'll generally approach it. Just a couple of extras. One of the big things that we wanted was an easy way to get data out of the utility. So we used to, when I originally wrote this, we had an export function, and what it would do is let someone save a file somewhere, and then an Excel file, a CSV file, any kind of file, and then it would export that data, and then when they needed it, they would have to go open that data. And I was always really interested in the idea of the copy to clipboard, but if you've ever used it in Mathematica and you actually copy the data, it's really nice for pasting in between notebooks, but it's not really nice if you want to paste it to Excel. So I wrote my own data, and then when I paste that, it looks a little weird right here, but if you were to paste that in Excel, it would be tab separated, and everything would look really nice. So that's built into all the utilities, and you can just export all that data really easily, and you don't have to do that second and third step. The save load, every utility that's in there right now has an option to save the current configuration, and I wanted something that was really generic to do that, and so I basically wrote this little code right here, and it'll take the name, whatever the utility is, and then all my variables associated with that. It'll write them as an association to a file with the string as the variable and then the value. And then similarly, when I load that back in, I can take those same strings and just convert them into symbols and then set the values. And it works really nicely, and I don't ever have to manually go through and set which variables I want to save. It's handled for each utility. Okay, finally, so advantages of Wolfram language for application development. Algorithms can be developed very quickly, and you generally require a lot less code, which I'm sure all of you are aware of, but when it comes to things like R&D projects, it's really nice to have, and it's really nice to do it that way. The limitations for me, as far as what I saw with application development, there were some strong limitations in the UI capabilities. I don't think you're ever going to be able to develop a professional, looking desktop application. There's just some limits in the way the notebook is set up. But I mean, I think you can get to something that looks pretty nice, and especially if it's for quick, internal development, I think it'll probably meet any requirements that you have. So conclusion, future of Alex, we've got a growing list of utilities to add. Right now, we're at 37. I think I'll probably easily get up to 50. We're dealing a lot more with the lab now, with our lab, and sort of coupling the engineering work with the lab, and there's a lot of opportunities there to expand further with that. And I've been really interested in the cloud opportunities and learning specifically about API functions as a way to call those instead of running these things through CDF. So all that might be in the future. So Wolfram Language obviously plays a very vital role at AFS, not just for me. I use it personally in every sort of work function I do, but also in the ability to distribute these CDFs to my colleagues, which get used daily as well. And lastly, I think we're all aware that Wolfram Language can play a huge role in the industry and sort of preaching to the choir, obviously, but I think it's all of our jobs to just increase that awareness and keep doing what we're doing, spreading the word, because it's a really powerful tool. So. And that's it. Thank you very much.